Leaving cert higher level, 2014 paper 1 question 7 starts with a Pythagorean triple. You're given the Pythagoras, a squared plus b squared is equal to c squared. You're told to let a equal 2n plus 1, b 2n squared plus 2n, and c 2n squared plus 2n plus 1. Pick one natural number n. Let's pick n is equal to 1 here, it's the easiest one. And verify that the corresponding values of a, b, and c form a Pythagorean triple. So if n is equal to 1, a is equal to 2 plus 1, which is 3. B is equal to 2 plus 2, which is 4. And C is equal to 2 plus 2 plus 1, which is 5. May as well do a little triangle with my C, my A, and my B. So 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. 25 equals 25. And we've got what we were looking for. So in part 2, you're asked to prove that A, B, and C with the same values will always form a Pythagorean triple. So a squared plus b squared equals c squared. We're going to have 2n plus 1 to be squared, plus 2n squared plus 2n to be squared. Is that equal to 2n squared plus 2n plus 1? All to be squared. So just a little bit of algebra here. We're going to get 4n squared plus 2n twice, which is 4n plus 1. And we're going to get 2n squared to be squared, which is 4n to the power of 4, plus 2n squared by 2n twice, so that's going to be 8n cubed. And then we're going to have plus 2n to be squared, which is 4n squared. So what have I got? 4n squared, 4n squared. The highest power first, so I've got 4n to the power of 4 plus 8n cubed plus 8n squared, and then I'm just left with my plus 4n plus 1. You could use binomial expansion for this one, or you could just multiply the brackets out, it might just be easier. So I'm just going to write another 2n squared plus 2n plus 1 beside it and get rid of my squared. So I'm going to get, so we're going to have nine little sums here. So 4n to the power of 4, 4n to the power of 4 plus 4n cubed plus 2n squared. Then I'm going to have 4n to the power of 3, this one by this one, and so on, plus 4n squared plus 2n. And then my last one, multiplying 1 by everything, I'm just going to get 2n squared plus 2n plus 1. So there's my 9 sums. Combine them. I'm going to get 4n to the power of 4 plus 8n cubed plus 8n squared plus 4n plus 1. And these two, you can see, are equal. Therefore, will always form a Pythagorean triple, or Paddy Pythagoras, as my brilliant maths teacher Mr. Maxwell used to say, the Irish mathematician, which I believed for years. Part B of this question, again, there's Pythagoras involved here. We're looking at ADEC, the rectangle, where AC is 7, AD is 2. So we can put a 2 in here. B is a point on AC, such that AB is 5. And P is a point on DE, such that DP is X. And we're told to let f of x equal PA squared plus PB squared plus PC squared, and show f of x is equal to that quadratic. Okay, let's look at PA squared first. So we've got a right angle triangle here to find PA. So we have a 2 and we have an x. So we can say that 2 squared plus x squared is equal to PA to be squared. So 4 plus x squared is equal to PA to be squared. We don't need to simplify it. Now we're looking at PB to be squared. PB to be squared. So we drop a line down here and say that this side is 2. To the left of P here is x, and the whole length is 7. So this one in here, this is 2. So this one in here, there's 5 between this point and this point, so this has to be 5 minus x. So again, this is going to help me get PB. So PB, we've got this right angle triangle. I have a 2, and I have a 5 minus x. So 2 squared plus 5 minus x squared is equal to PB to be squared. So 4 plus 25 minus 5x twice plus x squared is equal to PB to be squared. So we have x squared minus 10x plus 29 is equal to PB to be squared. Third one we're looking at is PC squared. Okay, this one here, PC. Again, we're doing right angle triangles. PC to be squared. So we have a 2 on the right hand side, so we need the base. And it's x to the left of p, so this base in green here, this whole thing is going to have to be, it's a total of 7, so 7 minus x. So let's draw that triangle. I have a 7 minus x, a 2, and this is going to help me get PC. So 2 squared plus 7 minus x to be squared is equal to PC to be squared. 4 plus 49 minus 7x twice minus 14x plus x squared is equal to PC to be squared. So 53 minus 14x plus x squared is PC to be squared. Okay, let's bring down the other two. So we're adding on x squared plus 4, and we're adding on x squared minus 10x and plus 29. So what's this going to give me? I'll write the x squareds first. It's going to give me 3x squared minus 24x. 57 and 29 is 86. And hopefully this is what we were looking for. 3x squared minus 24x plus 86. We have shown what was asked to be proven. Part 2, the function has a minimum value. Won't you see min or max? We're talking about differentiation. At x is equal to k. So we could complete the square and use that method, but it looks a little bit awkward maybe completing the square. So let's just differentiate it. So y is equal to, or f of x is equal to 3x squared minus 24x plus 86. So we know that minimum value, the slope of the tangent, which is dy dx or f prime x, the slope is equal to 0. So we differentiate this. I'll use f prime x, it doesn't matter. You could use dy dx is equal to 6x minus 24. That would have to be equal to 0. So we're going to get 6x equals 24. X is equal to 4. And to get my y value, we need to put 4 back into the equation. So 3 by 4 squared minus 24 by 4 plus 86 is going to give me 3/16, 48 minus 24 fours are 96 plus 86. So that's going to give me 48 just minus 10, which is going to be 38. So when x is 4, y is 38, and that's that minimum point of this quadratic.